Okay, here we will do concept check question 2, 3, 4, 5, and 7. 2, 3, 4, 5, 7. Okay, the first one, question 2. A. Consider the graph of the function y equals log base 6 of x. First, if you get the function, you should be able to draw the graph. Okay, log graph. Okay, let's look at the base. The base is 6, right? That means the base is bigger than 1. So the graph should be like this. Okay. It passes through 0, 1. Okay. So this is the point. Where is 0, 1? 0, 1. This is 0, 1, right? How about this point? This point is 1, 0. So that means the first one is wrong. When x is in between 0 and 1, it lies below the x-axis. When x is in between 0 and 1, so let me draw a vertical line first. X is in between 0 and 1. So this is 0, this is 1. 0. Okay, does it lie below the x-axis? Yes. Okay, so this is correct. When x is bigger than 1, so x is here. Okay, the graph lies above x-axis. Correct. B. Consider the graph of the function y equals log base 0.2 of x. It lies on the right-hand side of the y-axis. First, we can draw the graph. Okay. Since base is less than 1, so the graph should be like this. Does it lie on the right-hand side of the y-axis? Yes. When x is in between 0 and 1, does it lie above the x-axis? So first let me draw a vertical line to separate that. X is in between 0 and 1, so here. Okay. In this case, the graph lies above the x-axis, correct? When x is bigger than 1, it lies below the x-axis. When x is bigger than 1, in this case, the graph will lie below the x-axis, correct? Part C. The graphs of y equals log base 7 of x and y equals log base 1 over 7 of x show reflectional symmetry with each other about the x-axis. Is it correct? You can go back the last page. So I think we just did it. Y equals log base a of x and y equals log base 1 over a of x. They will show reflectional symmetry about x-axis. Right, I think we did that. So this one is correct. The graphs of y equals 1/3 to the power of x and y equals log base 3 of x show reflectional symmetry with each other about the line y equals x. Okay, I think we did this one as well. let me write it here. So for these two functions, y equals a to the power of x and y equals log base a of x. Okay, let me highlight that. This one and this one. Okay, for these two functions, since they are inverses of each other, they will show reflectional symmetry about the line y equals x. Okay, but let's have a look. The first function, 1 over 3. The second one, log base 3 of x. Are they inverses of each other? No, right? You may say y equals 3 to the power of x and y equals log base 3 of x show reflectional symmetry about y equals x. Or we can say y equals 1/3 to the power of x and y equals log 1 over 3 of base 1 over 3 of x, they show reflectional symmetry about y over x as well. But for these two, they didn't show reflectional symmetry. So, wrong, this one. Okay, question 3. Which of the following may be the graph of y equals log base 0.5 of x? So, the first thing that I observe is option C and option D must be ruled out. Why? Because these two graphs, they are exponential graph, right? Right? Exponential graph. So these two must be ruled out. Okay. The left-hand side one, this is the case when a is bigger than 1. And the right-hand side one, option D, this is the case when a is in between 0 and 1. So option C and option D, they are ruled out. Okay, so we still have option A and option B. So these two graphs, they are logarithmic graph. Okay, or simply say log graph. Y equals log base A of x. Let's have a look on the right hand side option B. You can see for this graph, when x increase, y increase, right? So this is the case when a is bigger than 1. And for option A, this will be the case when a is in between 0 and 1. Okay, so let's go back to the question. Y equals log base 0.5 of x. The base is 0.5. It is in between 0 and 1, and it is a log function. So that means we should choose option A. Question 4. Part A. Which of the above graphs may represent the graph of each of the following functions? The first one, y equals 4 to the power of x. As I have just mentioned before, first we should know the first graph and the third graph, they are exponential graph, right? And for the first graph, this is the case when a is in between 0 and 1. Okay, and this is exponential graph. The third graph, this is also an exponential graph, but the base will be bigger than 1. For the second graph, this is a log graph, and a is bigger than 1. The fourth graph, still a log graph, but a is in between 0 and 1. So the first one, y equals 4 to the power of x. This should be the third graph, right? Okay, the next one, y equals log base 4 of x. Log graph, base is bigger than 1, so this should be the second graph. Next one, y equals 1 over 4 to the power of x. Exponential graph, base is in between 0 and 1, so this should be the first graph. The last one, y equals log base 1 over 4 of x. Log graph, base is in between 0 and 1, so this should be the fourth graph. Part B, which two graphs show reflectional symmetry with each other about the x-axis? Okay, so now let's have a look for these four graphs. If I move the second graph to the fourth graph, let's look what will happen. I use a blue color, okay? I move the second graph to the fourth graph, okay? Do you see these two graphs? They show reflectional symmetry with each other about the x-axis, right? So that means graph 2 and graph 4. Okay, how about the y-axis? Now, I move the first graph to the third graph. I use blue color as well. What do you see? These two graphs, they show reflectional symmetry with each other about the y-axis. So this will be the first graph and the third graph. The last one, y equals x. Do you still remember? Let me use a green color to circle it. Y equals a to the power of x and y equals log base a to the power of x. They are inverses of each other, right? So they will show reflectional symmetry with each other about y equals x. Therefore, we know for the first two function, so let's say y equals 4 to the power of x and y equals log base 4 of x, they will show, since they are inverses, then these two functions, they will show reflectional symmetry about y equals x. So that means it should be the second graph and the third graph. But how about these two? Y equals 1 over 4 to the power of x and y equals log base 1 over 4 of x. They are still inverses of each other, right? That means these two graphs, they also show reflectional symmetry about y equals x. So you can answer graph 1 and graph 4 or graph 2 and graph 3. Both are correct. Okay, let's look question 5. The three curves in the graph represent the graphs of y equals log base 1 over 5 of x, y equals log base 5 of x, and y equals log x. Which of the following are true? Let us identify the function and the graph. Okay. For fx and g of x, these two functions, okay, you can see their curve are going up, right? That means the base should be bigger than 1. For the graph of y equals h of x, is going down, right? That means the base is in between 0 and 1. Okay, therefore, that implies h of x, it should be y equals log base 1 over 5 of x. How about y equals f of x and g of x? From the graph, we can observe the yellow graph, it is flatter, right? Now we will use the information that we just learned. For y equals log base 5 of x with a bigger than 1, the bigger the base, the flatter the graph. What does that mean? The graph of y equals g of x is flatter. That means its base should be the bigger one. So therefore, that implies this should be log x, because the base is 10. So y equals f of x should be y equals log base 5 of x. Now we can do the question. The first one, f of x equals log x. This is wrong. The second one, h of x equals log base 1 over 5 of x. This is correct. Number 3, the coordinates of A are 1, 0. Okay, we know all log graph, they all pass through 1, 0, right? So this is correct. Number 4, the domain of g of x is all positive real numbers. The domain of logarithmic functions, okay, is all positive numbers. It is correct. Therefore, the answer should be option D. The last question, question 7. In figure 2, the graph of y equals 2 to the 4 to the power of x cuts the y-axis at 1 and passes through B, 1, 4. C and D are the images of A and B after reflecting about the line y equals x respectively. Part A. Write down the coordinates of A on the figure. Okay, so the graph of y equals 4 to the power of x. This is an exponential graph, right? So this point A should be 0, 1. Okay, 0, 1. Part B. Mark the points C and D with the coordinates on the figure. The question says C and D are the images of A and B after the reflection, right? So we know that the coordinates of A are 0, 1. After the reflection by this line y equals x, okay, then point C, the coordinates of point C, it should be, we swap the x coordinate and y coordinate of point A. So point C should be 1, 0. I will show you later why this is the case, okay? And point D is the image of point B. So point B is 1, 4. So we swap 1 and 4. That will be 4 and 1. Okay, 4 and 1. So this is point D, 4 and 1. Part C, we sketch the graph of y equals log base 4 of x. Just now we know, we have learned y equals 4 to the power of x and y equals log base 4 of x. They are inverses of each other, right? That means they show reflectional symmetry about the line y equals x. Therefore, we can draw the graph. Let me use this one, this color. So the graph will be like this. okay, approximately.